All right, welcome to Local and Global Extrema Day 1. Today we're going to be taking notes particularly on the global extrema, or sometimes we refer to that as the absolute extrema. So without further ado, let's get to it. Okay, today we are going to focus on finding the global and local extrema from a graph. In fact, we're even going to refine it and just be focusing on finding the global extrema from the graph. And in order to do that, we need to be able to define what the global extrema is. So the definition is found right here. And if f is a function on an interval I, then y equals f of c is the absolute maximum if and only if f of c is greater than or equal to f of x for all x in I. So that is kind of math jargon heavy. When you break it down, the basic idea is the absolute maximum is going to be the absolute highest point on the interval. And there is a little bit of caveat to this, so I'm going to write sort of. And we'll see what I mean by that very shortly here. But basically, if you've got some curve and it comes to a high point, sure, we have two high points, but this is the absolute highest, so that is where the absolute maximum will occur. And the sort of has to do with what we're going to look at next. So in the next line it says, we can't say it's the biggest on the interval, but rather that there are none bigger. So very simple example of that would be if you had a graph that kind of came up to a high point and then leveled off. Any point on that level plane is going to be what the local maximum, or sorry, the global maximum is, will occur at any of those points. So it's just the highest value. There are none bigger than that value. Anyways, let's look at this graph here and talk about absolute max and mins. I won't talk about mins in depth. Min is just, instead of being the highest point, it's the lowest point, or the point for which there are none smaller. Okay, here we have a graph, and looking at this graph we can see that as we trace along the curve, we get to a spot where we reach a high point. There's actually more than one spot where there's a high point, and there's more than one spot where there are low points. So we want to find the absolute highest, and the absolute highest is going to occur at this spot. So what we can say is there is a absolute max of, our function is called g, so our absolute max of g of d, because it occurs at the value of d. So, and this is at x equals d. So there's two things we're finding. We're finding what is the max, and that's basically the y coordinate. And then we're also finding where is the max, and that is the x coordinate. So anytime we talk about max or min, we want both the of, the y coordinate, so that occurs at g of d, and usually we'll have numbers for that. And then we also want where, which is the x coordinate. And we have to pay attention to our questions, because sometimes they ask where is the max, and sometimes they ask what is the max. So as long as we list both what and where, then we cover the question completely. Now we want to find the absolute minimum, and in this case the lowest low occurs at this spot. There are none lower than that location. So what we can say here is there's a absolute min of g of a, whatever that winds up being, it's lowercase a, at x equals a. So there will only be at most, one absolute max and one absolute min. All right, let's do it on some graphs on the next page. Okay, the directions indicate for us to find local and global extrema, but I just want to focus on finding the global extrema, so let's cross that out. We'll get to local later. For this, the absolute highest point occurs right here. So our absolute max of 4 at x equals 3. And then we look for the absolute minimum, and our absolute minimum occurs at this location. So we can write absolute minimum of -3 at x equals -3. So we've got our of -3 at x equals -3. Let's move to the next one. Next one, we see that there's an arrow on the end, so this curve keeps going downward. And some people might argue then that the absolute minimum is -infinity, but the problem with that statement is the absolute minimum actually needs to occur at a point. And since this is not a point, but it just keeps going on forever, we actually can't include that. So we have to look for a different minimum. And we cannot do that because there is, some would argue this is the minimum, but there are points lower than that. So there is actually no minimum. So I'm going to write here no absolute minimum. But we can find a absolute maximum. We have a absolute maximum, and the absolute maximum occurs right there, and we can see we have a absolute max of 5 at x equals -1. Okay, I'm going to leave the third one for you to try. Go ahead and pause the video here, and then I'll write in the answers, and then you can restart it after you found your max and mins. All right, hopefully you were able to do that fairly easy. What we have is the maximum occurs at the highest point, which is right there, and then we drop down to the lowest point for the absolute minimum. All right, this is pretty easy when we're given a graph, but sometimes we're not given the graph and we actually have to create the graph ourselves. So let's take a look at that in example 2.
Look at this graph.
Okay, in example 2a, we must first graph the given function, and then we can talk about the extrema. So what we have here is a parabola that has been shifted up 1 unit, and we have a restricted domain. Looks like we go from -1 to 2. And once we draw our graph, we can see there is an absolute maximum. So we have an absolute maximum of, looks like 5. So absolute max of 5 at x equals 2. From here, we look for, whoa, my graph shifted. From here, we're going to look for the absolute minimum, and the absolute minimum occurs at this location. So we have a absolute min of, that's 1 at x equals 0. All right, moving to the next graph. Looks like it's the same curve. However, in this case, our endpoints are not included. So with our unincluded endpoints, what happens is we no longer are able to find a maximum, because the maximum is actually not a point. So there is no max, no absolute max. but we can include the minimum. So we still have the absolute min of 1 at x equals 0. All right, third graph. Looks pretty similar, except this one is a piecewise function. So what we have is we have the parabola everywhere except for 0. And then at 0, we jump up to a value of 2. So that's what this curve looks like. And we do have a maximum. So again, our absolute maximum is here. So our absolute max of 5. And again, if you don't know how to find that value 5, it's occurring at f of 2. So we can evaluate f of 2 and see that it's 5. So this is at x equals 2. And then our minimum, it looks like it wants to occur here, but we see that what's happening is the value actually doesn't exist there. So there is no absolute minimum. I mean, some people might want to zoom in and say that it's, really, really close to that spot. But unfortunately, we can only get infinitely close, and we can't actually arrive at a specific point. So we conclude there is no absolute minimum. All right, 3 more graphs, and then we're done with this section for the day. So sine of x, that's our trig function. Let's do it in black. And sine starts axis high, axis low. And since we're going 2 cycles, we want to draw it twice. Here we see that our absolute max is the highest value. So we have an absolute max of 1, and that occurs at x equals pi halves. And over here, which is going to be at 5 pi halves. Pi halves plus 2 pi is 5 pi halves. Our minimum is down here, so our absolute minimum of -1, and that's going to occur at x equals 3 pi halves and 7 pi halves. So it is possible for max and min to occur at more than one location. All right. Next one, I'll let you try to take a stab at that on your own, so go ahead and pause the video here, and I'll draw out the answer. All right, we have a straight line, and we include the endpoints, and so because of that, the endpoints are included, we can consider those our maxes and our mins. If the endpoints were not included, we'd actually have no absolute max or min for this equation. All right, the last one, a constant function, f of x equals 3, 1, 2, 3, from -2 to 4. And from here, we see that our absolute max is, well, our absolute max is actually 3. Absolute max of 3, because there are no values higher than 3 on that interval. And if we want to explain where that is, this actually occurs at all x. That upside down A means for all x that are in the interval of -2 to 4. So it occurs at several locations. Any x within the interval of -2 to 4. Similarly, we also have an absolute min, and the absolute min also occurs at a value of 3. And the location, again, would be for all x values that are in the interval -2 to 4. So that's pretty fascinating. Our absolute maximum and our absolute minimum occur at the same value, and that value is 3. So, all right, a question for you to consider as we move forward is, under what conditions does the function have both an absolute maximum and an absolute minimum? So when we looked at these graphs here, we saw that some graphs had both a max and min, and some of them were missing a max or a min. So ponder that, and we'll talk more in class. All right, thanks for watching. Hopefully today, after this video, you should be able to find global extrema from a graph. Global or absolute extrema. That's two different words for the same thing. Thanks for watching.